Hello everyone, so today I'm gonna solve this problem, balance a binary search tree. Okay, so what is happening here is one binary search tree BST is given to us, and basically we have to make this binary search tree as a balanced binary search tree. Now balanced binary search tree, what it is? So basically balanced binary search tree is something where for any node, okay, for any node in that BST, the left subtree and right subtree, okay, the height difference should not be greater than 1. Okay, so in general you can say that if we pick any node, the difference of their left subtree and right subtree height should not be greater than 1. It should be either 1 or 0. Okay, then we can say that yeah, this is a balanced binary search tree. So this is what we have to do is, so let me explain what would be our approach. So as per given in the question itself, this is the one binary search tree which is having only right pointers has certain value, left guys doesn't have. So it is also a binary search tree. So we have to convert this to a balanced binary search tree. Right now it is not balanced because see here the height of it, what is the height of it? Height of right subtree is 3, right? And how height of left subtree is 0. So 3 minus 0, this is 3, right? So this is definitely not a balanced binary search tree. So what we have to do is basically first of all we have to get the Inorder traversal values of that binary search tree, okay, into some array list or array you can say. So if we do the Inorder traversal of this binary search tree, this will give us the increasing order, right? So we will have something like this 1 2 3 4, right? So we will first of all we will get all these values in a form of Inorder traversal. I will tell you why we are doing this way. Okay, so anyway our Inorder traversal would be still same even when we will make the change in the binary search tree, right? So now after, from this binary BST we have converted our thing to a array list. We have gotten all the Inorder traversal thing. Now what we will do is we will always get the middle point of this thing. Okay, so let's say this is our 0, and what is the size of it? 4, right? So 4 minus 1. So we can have two variables, left and right. So here if we pick left equal to 0 and right equal to size of this array list minus 1. Okay, so this would be 4 minus 1 equal to 3. So this would be our range. So we will calculate the midpoint of it. Okay, so mid equal to left plus right minus left by 2. So we should, whenever we are getting midpoint in binary search or any such kind of things, we should always use this formula. We should not go to left plus right divided by 2, because most of the case that might work, but think about when we have the overflow of the values. Okay, in that case we might face the issue in that formula. So we should always have a good practice to use left plus right minus left by 2. Okay, so we are getting mid. Now for this mid, that should be our root, right, when we are starting. So we can definitely make the root with the mid. So we can have this 3 as our see here left is 0. So let's calculate it. Okay, so 0 plus 4 0 plus 3 minus 0 by 2. So basically what it would be? It would be our yeah, so see here left is 0 and right is 3. So 3 minus 0 by 2. So basically this is 0 plus 1 point. So this is 1 only, right? So mid equal to 1. So our root should be start with 2. So 0 and 1. What is there at 1? At 1 it is 2. So we have to make our whatever balanced binary search tree. This should be our root. Okay, so let me do the dry run of entire code. So I'm removing this this part because it is of no use now. We already got the array out of this BST. So now we will go for our resultant BST. So see here we have got 1. So 1 the value is 2. So first our root node would be 2. Okay, now for this root node we have to call the same function on the left side as well as on the right side of it. Okay, so we have to call the same function. So what would be the left child of it? Left child of it would be whatever value comes from the left side. and right child would be whatever comes from the right side. So if we call it this function util, then see here we will come here. So left side would be our, so in second set our left would be still 0. Okay, so in this portion I am talking, so left would be still 0, so this would be 0, and its right would be what? Its right would be mid minus 1. Okay, so its right would be mid minus 1, which is again 1 minus 1, so 0. Okay, so for this portion it is 0. Now let's calculate for this portion as well. Okay, this guy belonging to this one, and we have to calculate one more, which would be here. So for right side it would be what? Left would be mid plus 1, right? So our left would be, so left will be mid plus 1, so mid is 1, so 1 plus 1, left would be 2, and right would be still 3. Okay, so this is two part which we just got after getting our root node. So right is still 3. Now we will call separately for these functions. So see here, this is right, left, both are 0 plus 0 divided by 0, so mid would be 0 only. Okay, so when mid would be 0 and at 0 we have 1, right? So we will come to here as 1. Okay, now go to this side, left. Okay, so find the mid of it. It would be 2 plus 3 minus 2 plus 1, right? 2 plus 3 minus 2 plus 1 divided by 2. So 3 minus 2 divided by 2. So what it would be? It would be again 2 only. Okay, so this would be our 2. So at 2 what we have? It is 3, right? So our right child would be now 3. Okay, now similarly see here, this is already done. So for this portion if we go, so what it would be? Our left would be here 0 and right would be mid minus 1. So 0 minus 1. So our, so left would be basically become the greater than right. So this is invalidated condition. So we will stop here only, but we will look for this portion. Okay, so here let me remove this remaining thing. So left part we are already done. We will look for, so at 3 we have placed right at the right child. Okay, so we have to take the next configuration of it. So mid would be, so what would be left here? The left would be mid plus 1. Okay, to the right side. So this would be 2 plus 1. So our left would be in the new thing, it would be mid plus 1, which is 2 plus 1. So left would be 3 and right is also already 3. Okay, so now what we have to do, we have to get the mid of it. Okay, so mid also would be 3, right? Left plus 3 plus 3 minus 3 divided by 2, right? So this would be also 3. So again we will get the its child. Okay, so let us do that. At mid 3 what is there? At mid 3 we have 4, right? So this will go to right side of it, and this is 4. Okay, now if we further go with the this thing, right, we have mid equal to 3, right equal to 3. If we go to right side, it will violate basically when left is equal to mid plus 1, right? So it will become, left would become 4 and the mid is still 3. So in that case our condition would be violated, because left should be always either less than or equal to right. Okay, then only it would be valid, right? So for this reason we are calculating everything. So finally we are done with this part. Okay, so this would be our final balanced binary search tree. You can see here, this is our root, its left child and right child. It has height 1, it has height 2, and it has height 1, right? So difference is 1 only. So now we can say this is balanced binary search tree, BBST. Okay, so this is what we have to do in our code. Let me write down a code of it. See, this is my code here. So first of all, what I have done is here in this portion I'm just doing one thing, right? I just written a Inorder traversal function where I am passing the array list. I am storing all the values, Inorder traversal values, into this array list. Okay, So this is our Inorder traversal. I'm calling left side, then I'm adding the value and then calling right side. So I believe you guys already know how to do Inorder traversal. Then we have this second part. I have written another method called macbst. Okay, so here what we are doing, we are passing the left, we are passing the right, and we are passing the array list, which we just populated here in this function. Okay, so see here, this is my check condition, that if left is greater than right, we are returning null. Otherwise we are creating mid, and then I'm creating the nodes of it. So root equal to new tree node al dot get mid, whatever at there mid. Now see here, we are going in the bottom up approach. Okay, so see here, I'm going to whatever root I have calculated, root dot left equal to, I'm calling on the left half of the our array list. See here, and similarly for right child, I am calling the right half of that array list. Okay, so in that way we are finally returning root. So you guys can understand this is a bottom up approach. See here, right after getting this root, we are populating the left and right child, and then we are returning this root. Okay, so inside this entire definition would be taken in these sub arrays, in these sub recursive functions. So this would be our approach, and finally here I am calling my function. I created one array list and then populated it here, and then calling it 0 and al dot size minus 1. Okay, so let me execute the code. So yeah, so let me submit it. Yeah, it is working fine. So thank you for watching the video. If you have any concern, please make a comment.